objective of this video is to perform sentiment analysis on a dataset called Sentimental.csv and create the sequential model and save the model and load it for the different dataset and perform sentimental analysis on a different sentence that has been given. So initially, let's see what is the model that we are saving. So basically, we are reading the data from Sentimental CSV, and the data has been only two columns that we are interested are text and sentiment. And we are showing you the value, the size of positive and negative size the data set. This is the one. And iterating over through the data set, we are creating a sequential model and using LSTM with a dropout value of 0.2 and recurrent dropout of 0.2. And the loss function that we are using is categorical cross entropy with an optimizer being Adam optimizer. Using the label encoder, we are transforming the data into sentimental data and encoding them into integer thing and splitting the data set into train and test and using the tensor board and sending the data into the tensor board logs. And finally, we're fitting the data into the model and performing and finding the score and accuracy of it, so which the logic I already ran for. So basically in each epoch you see the different accuracy from each epoch. So I've given as 7 epochs, so if you can see from the program on the model.fit, epoch has been given 7. That is why we see it's running on 7 epochs, and I'm evaluating the model and saving the model into this .yml file and load. This program is basically uses the model that has been already been compiled for the previous code over there, and we are running onto the new string and evaluating the performance of the model. So basically we have loaded from it, and the input vector has been divided into chunks. We have tokenized the sector, and this is the final input vector that we have got. And the other objective of this program is to use the same source code and perform a grid search CSV on that model. The same logic code here was again read from Sentimental.csv dataset, and we have done the same data pre-processing for this. We created a sequential model and use LSTM for it so that it remembers the previous words. And it's the same, we use label encoder for it. We have split the dataset into train and test, and we have built a Keras classifier on top of it and performed a grid search CSV on the dataset, and the value, the best score that we got is printed out here, so which is 0.845 with the batch size being 64 and epoch is 2. And finally, run the same source code on different dataset called spam.csv. The logic entirely would be the same, and evaluated the performance of the model with the loss being 0.7% and accuracy being the 98%. Thank you.